Well, good morning. Welcome to the Computer Security Seminar at Purdue University. Our speaker this morning is Brian Carrier. He'll be giving us a talk from his research area today titled Defining a Digital Forensic Investigation. Brian?
Thanks, Freddie. So my name is Brian, again. I'm a PhD student here at Purdue. And my area is digital forensics. And I kind of have the, I did my master's here a while back, took some time off, worked for a while, consulting world, and came back and was doing forensics while I was working as well. So it's kind of an area that I'm working in terms of providing more theory into an area that has very practical to date so far. And the basic goal here is basically to define what we mean by forensic investigation, put some theory into this area. So basically outline is to get some background on the area, discuss some of the process models that exist, define what we tried to solve with our problem and our approach to doing this. So the basic background. So we ask, what is digital investigation or what is digital forensics? It's kind of one of these buzzwords that forensics is kind of thrown with every word these days just to kind of give some marketing, whatever. So we have to define actually what this process is that we're defining as this investigation. And it's basically, the definition really is it's a process that develops and tests hypotheses to answer questions about digital events. It's kind of an academic definition here. And the basic problem here is that we have some event, that there are some questions that to ask. So we have a server break-in, or we have some employee is doing something they shouldn't be doing, and we have questions about this, such as, who or what caused this event to occur, when did it occur, when did the break-in happen, why did it occur, some very basic, questions that we want to answer. So the process is we want to develop some kind of hypothesis about why it happened, or, and try and find evidence to support these answers so we can give answers to people who are asking them. So some common, examples here. We have some kind of network server that's been broken into. It could be a web server or some other server that's been broken into by hackers, or as part of a corporate espionage type of thing, or trying to get intellectual property out of the system. We may want to find out, who broke in, what they had access to, how long have they been there, would they install, would they take, all this kind of basic, questions. We could have, in a corporate environment, most places have some kind of corporate usage policy of, I will not use this computer for, corporate gain of another company, or viewing pornography in the office, or various types of basic things that you can't use the company for. If HR finds you doing this, they may want to hire an investigator to find out whether you have been or not, to look through email or your web caches or various things. The third one is kind of unfortunately the most common investigation actually out there, which is looking at contraband images, which is generally child pornography. Most law enforcement spend most of the time investigating this, of people downloading this and having these contraband images, which are illegal to have. So this is kind of a common investigation to occur, just a finding if they exist or not on a system. And then another kind of investigation area is a suspect in physical crime that owns a computer. And this is actually another kind of increasingly common thing of, we have someone who commits a murder or is suspected of committing a murder or kidnapping or various things, and they go to the computer and they have MapQuest directions to where they met someone, or they have various drug terms on there, or Google searches on various things, and it's just kind of additional evidence of what they were doing in this actual crime. So this actually kind of happens more and more now with pretty much every investigation. There's some component of the digital aspect now that we have computers in all parts of our lives. So what is the state of the art in the area? Well, it's been driven by practical needs. And it's kind of started in the 80s with law enforcement of whatever they needed, something, a tool is developed. And actually, in the original days, basically, you would take a hard drive out, or you boot the computer. You'd find the computer, you turn it on, you poke around, you look at various files, open things up, and various things. They realized this was kind of bad because they're overwriting evidence in the process. So then they realized that, we can take another computer, put the hard drive into it, mount it, view it. Again, we're modifying some things. And to date, now we actually have specialized tools that we bring it into. It's read-only, we don't modify it. And it's a much better specialized tool that we have. But the main point here is it's been driven by practical needs, and there's no underlying theory. If you look at other forensic areas like biology or DNA or fingerprints or event reconstruction of trying to find the trajectory of a bullet from where it came from, these are all founded upon basic scientific principles of physics and biology and chemistry that existed way beforehand. I mean, we all did the trajectory examples in physics classes, and it's not really a science that was developed purely for this topic. Whereas this area, we're actually developing a lot of stuff practical-wise without underlying theory. To date, most of the stuff is on the file system and application data. So we're looking at files or deleted files or recovering files, various application metadata. And there's basically 5 or 6 common specialized tools that are out there that actually are helping us process. So, process models. So as we get into we define what this is, one of the reasons we looked into was, okay, what are the general process models that are used in this process to define this, and how can we use this to actually defining what the investigation is in more grounding terms. So the United States Department of Justice has guidelines that they have documented. And these came, I think, the late 90s, 98, 99. These were published. And the goal of these guidelines were basically to give to police officers going to a crime scene, a house, or a building, or whatever. And if they find a computer, to give them general guidelines of what to do with it. Don't ignore it, because it may contain evidence. Give them some basic, references to what to do. So they have 5 phases on here of their guidelines. The first one is preparation. This is kind of, before the event or incident ever occurs, to have your tools and equipment up to date, training, basic, readiness types of things. First phase, when you get there, kind of collection, you search the location for possible, things that may contain digital evidence. And we collect them, we copy them, we make a copy of them or bring them back to our lab. Next thing is examine them, we review them for possible evidence for looking for documents or images or files, whatever we're looking for. We have analysis. It's basically reviewing the results for their value. I'm personally not a big fan of this term. If you actually look up the definitions of examination analysis, they actually cross-reference each other. So examination is a form of analysis. Analysis is a form of examination. So the analysis is more like an interpretation of basically we find our evidence and our results, and we interpret them in the bigger picture of what this means in the case. And the last thing is actually reporting, where we document the results of our investigation for other people. So here's an example. So we have a scenario. We have a person suspected of creating forged documents, so check forgery or identification forgery or some kind of forged documents. And they're suspected of doing this on their computer. So we get our police, we have our search warrant, we raid the house with shields out and everything else. And basically, here's the process that we go through in this scenario. So preparation, we have our tools updated, we have people trained to use them and know what they're doing. They're certified. Then we go to the collection. So we go to the house and we find some computers, some printers, and several CDs lying around the house. So this is kind of the collection phase. We find these things. Well, the first thing we can either do is we can either take them all back to our lab, or we can just make copies of them. So this is kind of, we'll go through the copying process here. So here's the basic, very simple process of how we go about copying this. So the first thing we'll do, who just had basic cryptography classes? Is that one pretty much? Okay. So the first thing we're going to do is run the MD, this is all in Linux, basically. So run the MD5 sum command. MD5 is a cryptographic hash sum. Basically, you give it a bunch of data, and it spits out some unique, or not unique, but it spits out a 128-bit value corresponding to that data. If you change 1 bit in there, it's going to give it a different value. So the goal here, what we're doing is we're in a Linux system here. We have dev.hdd, which is a file that corresponds to the actual disk that we're analyzing. So this is the suspect's disk we have. And we're going to take the MD5 value of their entire disk on the computer. So we read every bit from the disk and give us the hash value of the system. This is basically our signature, or our checksum of the actual computer we're investigating. Our next step here, we use the dd command, which is another Unix-based command that basically moves data from one location to another. It's kind of a systematic way. And so here in this command now, we're actually reading this suspect hard disk, and we're basically writing it to some other file called mount case disk1.dd. So basically, we're copying every sector from the disk and putting it in some other file on our computer. And then we again run the MD5 command on this file to get its hash value. And the reason we do this is basically to verify this process was accurate. If any time in this process we didn't copy a byte or a bit or whatever, there was some error in the process, these two values will be different, and we know we haven't made an accurate image. And this becomes important because we're going to have to testify in court that we actually analyzed the accurate data. So if we don't have this process,